Hello and welcome to Senior Code Review Buddy. My name is Chris and today I'm going to talk about the importance of having a single source of truth in your code. Now, this is probably something you've heard of when people are talking about documentation or code repos, but I want to talk about the importance of having a single source of truth in your code itself, as it can make your code much easier to understand and reduce the need for some error detection and error handling. Now, what I mean by single source of truth in code is that if you've got a value, like the state of an object, you should have that value stored in just one place. It's source of truth. For example, if you have a child and a parent class, the child's state should only be stored in one of those classes. Either the parent owns that or the child owns that, but not both. The reason we want this is the same reason we always want just a single source of truth. So we know which value is correct if there happen to be mismatches. If the parent and child both store the child's state, what is the state of the child if the parent says it's disabled, but the child says it's enabled? We don't know. If we get into this state, we've got a problem. We'll need to add some detection code to see if we get a mismatch at any point. And then we'll need error handling code. If only one of these classes was responsible for holding the state, it would be impossible for there to be a disagreement, as with only one source of truth, there's nothing that can disagree with it. So we would make it impossible for there to be a state mismatch, which means we don't have to have error detection code or code to fix those errors because they just can't happen. Now, violations of a single source of truth aren't always repeated variables in different spots, like this example. Sometimes they can be a bit tricky to see. I've got a few examples to walk through to help you get better at spotting and hopefully fixing these issues. So for our first example today, we've got a simple little roller coaster class. It takes in the name of a roller coaster, the enum state of the roller coaster, and a string representation of the roller coaster's state. And if we run it, yeah, all we do right now is sort of print out the roller coaster name and the state. So it seems like we're taking in this state string mainly for human readability purposes. But this is going to be an issue. We take in state and this state string, but we don't have anything here that confirms or enforces that they refer to the same state. We could have a mistake, and instead of passing in closed permanently here, we could pass in open. And if we run it, it says the roller coaster is open, although the enum state says it's closed. Which one of these states is correct? What's the actual state? We wouldn't know. I think that if I was looking at this, I'd probably assume that this enum takes precedent over the string, and it should be viewed as the source of truth in a disagreement. But other people might disagree with me and might think that the string probably should be viewed as the source of truth. So what I think we probably should do here is just get rid of state string and modify our enum to print out the same human readable string that it had before. So we'll get the same functionality as this, but we won't have state in two different variables. So let's start by just removing this state string completely. And then here we'll print out the enum instead. So, oops, and we'll get rid of it. Well, get rid of this, get rid of this, and get rid of this. And if we run it now, yeah, so it does work. It is showing the correct states, but it's not in the human readable strings we probably wanted. So what we can do is we can just get the enum to print its state itself. So if self equals self dot under construction, we can just return the human readable string under construction. And then we can just do this for each of these. Maintenance. we'll also raise an exception here, unknown enum. And if we do that, yep. So with that, we're printing out the same values as before. And so this is good, but we can't have a disagreement on state anymore because we're only storing state in one variable. So this is going to be much more maintainable code. All right, and with that, let's go over to our next example. All right, so this example is something I actually ran into recently while working on my deliberate practice app. We've got a practice session class here, which inherits from the Django model class. It's okay if you don't know sort of what that means. All it really matters is that practice session is basically a data class. Conceptually, a practice session is a collection of practice sets and a start and an end time and a state. The state, as listed here, can sort of either be active, which means new practice sessions could be added, or it can be finished, and they can't be added. So we see that we've got our start time and our end time and our state stored here as part of the class. The practice sets are actually handled in a different way, so they don't show up here. Now, as I looked at these three variables, I realized, I guess the state can only be finished once we've added the end time. So I started wondering if I could add a monitor or a watcher or something to make sure that when we set a value to end time, state gets changed from active to finished at the right time. But then that made me wonder if, what was I going to do if the state was marked as finished, but there wasn't an end time? Or we do set the end time, but state is still marked as active. These conditions don't make sense to me. They're error states, and I would need to figure out how to detect and handle them. And now this is looking more like I don't have a single source of truth here. State and time are duplicating some of the same data. With how I've been describing things, state, it's actually kind of just telling us, in theory, if end time has been set or not. If end time is null, state should be active. Otherwise, state should be finished. So all that having state as a variable here is doing is introducing the ability for there to be inconsistent states. So what I did was, instead of making state a variable of the model, just made it a function. And then I can compute and return the correct value for state based on the end time. So let's do that here. We'll start by just deleting the state variable and just replacing it with a little function, state. And then all we want to do is, okay, if end time is none, it doesn't exist, well, we know the session is still active. So we return state dot active. And otherwise, state's got to be finished. So we'll return state dot finished. And that's it. And we now can't have a mismatch between end time and state because state's deriving itself entirely from end time. I guess one little thing I'll mention is, in theory, we could be checking here that start time is getting set correctly, but start time actually will always get created as soon as this class is created, so it can't really exist in a non-existent state, so we can just worry about end time for now. All right, and with that, let's go to the final example. So this is an example I got from some chess code that I asked ChatGTP to generate for me for some other videos I did. Now, I didn't copy all of the code over. Instead, I just copied over this one function and sort of the calling code for it. Now, how this calling code basically works is we look at the board at the desired position to get the piece, and then we call generate piece moves with passing in the piece and the two coordinates. Seems pretty simple. Now, this calling code lives in the same class as generate piece moves, so they both have access to the same self, which means they can both access self.board. So, question here. What if I've got a typo here? What if I get the piece at RC, but I accidentally pass over CR, or CC, or RR? It's not going to probably work the way we expect, because generate piece move is going to be getting sort of a mismatched state. So it's going to probably be generating a move for a piece that isn't at the square. Now, as before, I think it's clear that we want to try and prevent this from happening. So how can we avoid passing in conflicting data into generate piece moves? Well, since we know how piece is generated, and this function also has access to this board, let's just remove piece as a parameter and just make that the first thing that happens here. And now with this, we can't be given a piece that isn't at the given location because we're using the given location to determine what the piece is. So now it's impossible for this function to get called with an incorrect piece. It's the function's doing it itself. So we have fixed this, we can't get that invalid state. And while we're here, I think hopefully we can see that, okay, we've got all these other functions as well that are also passing in piece and the 2 coordinates. And they're also members of this same class. So they currently suffer from the same problem that we could have mismatches. But just like this, we can just not pass in piece, just pass in the coordinates. And if they need piece, they can generate it for themselves. But otherwise, they can't have a conflicting inputs. So this result, I think, is much nicer than what we'd had originally, and we've taken out the ability for there to be mismatches. Thanks for walking through those examples with me today. Hopefully, this has helped you get some ideas on how to identify code that has multiple sources of truth, and how to fix it. Let me know in the comments below if there are times where having the same state stored in different locations could be advantageous. If you enjoyed this video, please consider hitting the like button below and subscribing. If you have any comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks. Have a great day.